here's some modern tools. You know, with Modbus, we're all used to going center to positive, center to negative, reading 2.4, 2.7 volts. We're all used to troubleshooting it. Like, how many times have you been here? Something's going offline, and one guy's on one end, and you're at the controller, and he unplugged. Is it good? It's on now. No, good. No, the other one went off. Okay, wait, here, I'll put this one. No, that one's down. They said this. Dude, which one? Okay, all off now? What the hell? We've all been.
Yeah.
I've spent 2 days trying to find Modbus, looking at every single wire and make sure one strand isn't touching. We've all been there. That's so last year. Let's get better. So I want to introduce you to two of my favorite tools. This one is a intensity meter. It reads the intensity of a magnetic field, kind of like an amp probe. But check this out. It reads in microteslas. Why? I don't know. But you can see it's red. I'm reading 290 microteslas. This is my Modbus for a Corel controller. This is a Modbus to USB converter. And they keep dropping these things offline. Nobody can figure out why. What do you see right here? 1, 2, and there's 2 more. They ran it by the transformer. Transformers are hit up with magnetic induction, magnetic fields. So they're running straight through the magnetic field. And if we look on an oscilloscope, which we will, I would see all this noise. So this is I paid $15 for this one. Nice little tool, Amazon. But here's my boy Pikachu. This is my oscilloscope. I used to use these in the Army. He's small. He fits in my backpack. I have a Pokeball for him. And here's how he's going to work. So here's Pika. I have a cable that goes to my laptop. When I bought this, it has software. This software is going to give me a DC signal. I'll show you that in a minute, a square wave. Remember, Modbus is a voltage, a DC signal. We know that because it says 2.6 and 2.4 volts DC. All I'm going to do is read that DC signal. Then I take my probe. I come up here to my controller. This happens to be a Corel Boss, but I've done it with Emerson. I do it with Copeland, and it works Modbus or Lawn. I can do this with microthermal as well. But what I'm going to do is put my meter leads in series, in parallel with my Modbus signal. And so what I'm going to see is, if I run this is a beautiful square wave. Notice the amplitude, see how it's transmitting. Matter of fact, if I hold my laptop up to my controller, where I have that TX and RX light that's flashing, that will flash at the same rate. And so that's a beautiful signal. And so if I go here, that's a horrible signal. The amplitude is too low. There's no transmission and no receiving. So what did we do with this? I want to go quickly on here. This was on 40 cases on one Modbus network. The first thing we did, 40 cases. How the hell are we going to troubleshoot that? Well, what we're going to do is disconnect code case 20 and disconnect 21 through 40. As soon as we did that, the signal came up. We were good. So we just said the first 20 cases aren't good. So what we did, we added 5 more cases. When we added the 5 more cases, the signal went to this. So we knew the problem was between 21 and 25. Then we broke it in half again. We were able, within 40 minutes, find a broken wire in conduit on the Modbus circuit in 40 minutes. 40 minutes, broken wire in conduit. So let's get smarter, use better tools, be smarter with our smart tools. Matter of fact, if you buy one of these, I have 3 subroutines I use that I've already pre-set up. If you send me an email and $100, no, you send me an email and I'll send you my subroutines.
No, it should be.